And for the future of everything tonight, we are diving into the abstract realm of quantum computing. And you've probably seen images of a quantum computer. It's this thing that looks kind of like a golden chandelier instead of a everyday desktop. But that is really just the refrigerator and the freezer part of the whole contraption. The real magic comes down to what a quantum computer can actually do. And full disclosure, I have been trying to wrap my head around that question for months now, reading books, even after a look inside of Google's quantum AI lab in Santa Barbara. And that's where we found that what seems like the science fiction world of quantum mechanics is just another day at the office. We live in a day and age where humans are building machines to do things we still can't even dream of.
We like to think about this as the place where we're going to build the future of computing.
And here at Google's Quantum Computer Lab in Santa Barbara, California, that future is right around the corner.
Okay. Wow. I'm just blown away.
But before we try to tackle the mind-boggling question of what a quantum computer even is, here's a quick crash course on how it works. In classic computing, behind everything on our screens, our phones, our CPUs, is a code behind a code that basically boils down to either a 1 or a 0, on or off, and that's a bit. But quantum computers run on quantum bits, or qubits, which aren't so binary. Think more like nature, or a waveform, or a coin that spins so fast it's both heads and tails all at the same time. And that is the magic behind a qubit.
It allows us, in our lowest energy state, to operate not only 1 or 0, but a superposition of multiple states.
It's almost everything in between.
Almost
1, 0, both at the same time, neither, everything in between.
And then comes the process of shrinking and etching qubits in aluminum onto tiny silicon wafers.
I can't even see them with my naked eye. These little plus signs, those are qubits.
And stacking qubits leads to exponential power. A 100-qubit quantum computer could perform over 1,000 billion calculations almost instantly.
The sound that we're hearing, is that?
Yes, the sound that we're hearing, that is the sound of the refrigerator.
Cooling their quantum computers to temperatures of just thousandths of a degree above absolute zero.
It's colder than space.
It's colder than outer space.
Only at beyond frozen temperatures can these qubits start to magically vibrate in frigid and tangled harmony. And then comes the really complicated question. What can a quantum computer actually do?
How does this type of computing power compare to, I don't know, I mean, a phone? It's different.
It's for a different application.
Got it. I can't FaceTime with that. But I could do some crazy math.
Imagine that you've got a super tall closet, has 1 million drawers in it, and a sock is hidden in one of the drawers. On average, you're gonna have to open 500,000 drawers to find the sock. With a quantum computer, you'd only need to open 1,000 drawers on average to find the sock.
Now that's a hard concept to follow because it almost defies logic. But the dream is to someday use that kind of quantum magic for things like modeling fusion to create unlimited energy, designing proteins to cure disease, or unlocking new physics. The possibilities of quantum computers are seemingly endless, and that's why Google is teaming up with the X Prize Foundation, offering $5 million to whoever can come up with the best real-world application. But for now, one of its most supreme feats is something that sounds so easy, at first I thought my 3-year-old could do it. Think of a number, any number in the whole world.
5.
5? Is that your final answer? But ask the top physicists in the world, and coming up with a truly random number has been pretty much impossible for humans until now.
We, as human beings, subconsciously put in a method to the madness. Computers need an algorithm that is a way, a method, but the method itself defies the random number generation.
As for the future of computing, just like trying to imagine how these massive machines that filled rooms with tubes and couldn't even play Pong still helped us with the math to get us to the moon, trying to envision where quantum computers could lead is an exercise in science fiction.
Some problems are calculated to take 10,000 years, 100,000, a billion years. So what we're trying to do is create a computer that works in a totally different way.
A warp
just
drive.
To access.
You guys are building a warp drive.
For some types of problems.
Right.
Now, that same warp drive is maybe going to be terrible at some of the other problems that we use classic computers for
the
today.
warp drive is not great at parallel parking, but getting across the galaxy, much more efficient.
Exactly.
Thanks for watching. Stay updated about breaking news and top stories on the NBC News app or follow us on social media.